underneath the impressive outputs of Gen AI are real and serious limitations. We'll walk through 4 challenges that researchers and developers are grappling with. The first challenge is data quality and bias. A generative model learns patterns from its training data, which means if that data is unrepresentative, the model will reflect those patterns. Techniques like oversampling and undersampling can help rebalance the data, but each approach comes with its own trade-offs. The deeper problem is that bias often hides inside datasets that seem large and comprehensive. The second challenge is data privacy. Large language models can memorize the training data itself, including names, email addresses, phone numbers, and other sensitive information. For organizations training their own models on proprietary data, this is a risk. Mitigation involves anonymizing and pseudonymizing the training data before it reaches the model, using smaller, faster AI models. The third challenge is cost of computation. GPT-3 was estimated to cost between $4 to $5 million in compute. A single high-end GPU can run over $30,000, and large training runs require thousands of them simultaneously. Beyond hardware, there is power, cooling, and data center infrastructure. Training from scratch is gated to large tech companies and well-funded research labs. The answer for everyone else is small language models, purpose-built, narrow models that accomplish specific tasks at a fraction of the cost. The fourth challenge is the ethical dimension. Gen AI can produce deepfakes and synthetic media to impersonate people, spread misinformation, or manipulate public opinion. It raises intellectual property questions, since models trained on copyrighted content may reproduce that material in ways that challenge legal frameworks. The automation of creative and content generation tasks is displacing workers. Watermarking systems, plagiarism detectors, and content moderation services are all part of the solution. The fifth limitation is around creativity. Generative models are extraordinary pattern machines, extending what already exists with impressive fluency. But the kind of creative leap that produces something the world has never seen before remains out of reach. These models reflect their training data. They are closer to imitation than true novelty. As generative AI continues to evolve, new challenges will emerge alongside new capabilities. The goal is to understand AI's limits clearly enough to build responsibly, deploy thoughtfully, and keep humans meaningfully in the loop.